In this video, we are going to discuss how to calculate centripetal acceleration of an object in circular motion. The question says, what is the centripetal acceleration of the moon? The period of the moon's orbit about the Earth is 27.3 days, measured with respect to the fixed stars. The radius of the moon's orbit, Rm, is 3.85 times 10 to the power 8 meter. Now let's sketch the problem. So let this be Earth, and the moon orbits the Earth in a circular orbit. The orbital radius, or the distance of the moon from the Earth, is Rm. And I will write here Rm is given to be 3.85 times 10 to the power 8 meter. And the period of revolution of the moon around the Earth is 27.3 days. We can convert this time from days to second. We know every single day has 24 hours and every hour has 3600 seconds. 3600 seconds because every hour has 60 minutes and every minute has 60 seconds. And when you multiply 60 with 60, you get 3600 seconds. Question wants me to find what is the centripetal acceleration of the moon. So centripetal acceleration is AC. Now the rule for centripetal acceleration is AC is equal to V squared over R. So I know the radius R, which is the orbital radius of the moon from the center of the Earth. But we don't know what is V, which is the linear speed of the moon or the tangential speed. So tangential speed of the moon goes like this. This is V. Now how do we calculate this speed? We know that speed is defined as the total distance covered over the total time. And when the moon is orbiting the Earth around a circular orbit, the total distance covered is along the circumference of the circle, which is the perimeter of the circle. And the value of circumference is given as 2 pi r. And the time it takes to complete one revolution around the Earth is t. So I can calculate my linear speed or tangential speed of the moon by taking the equation 2 pi r over t, where r is the orbital radius of the moon and t is the time the moon takes to complete one revolution around the Earth. Now I can substitute this value of v in my equation for acceleration. So we write for acceleration again. Centripetal acceleration AC equals, in place of v, I'm going to write this expression 2 pi rm over t squared divided by the radius rm. This small r I'm going to write as rm, which is the radius of the moon's orbit. Now we can solve this as, when you take square of 2, it becomes 4 pi squared, square of rm over t squared, and this rm. I can cancel the square here and the rm here, and you are left with 4 pi square rm over t. Now we can substitute the values to calculate the centripetal acceleration. We get AC equals 4 pi square. R is 3.85 times 10 to the power 8 divided by t, which is 27.3 times 24 times 3600. So you see, I did not calculate the value of t over here. I can directly substitute that in my equation at the bottom. And you need to take square of the t. So we do square. When you solve this, you will get your centripetal acceleration as 2.732 times 10 to the power negative 3 meter per second squared. This is my final answer. Now, if you don't want to solve this expression, if you don't want to simplify this expression, you can substitute all the values right here. You can put the value of Rm and T on the top, but make sure when you put this value, everything must be squared. And the Rm at the bottom is not squared, it is a single value. So you can substitute all the numbers here and you will still get the same answer if you do not want to simplify the term. So this is how you can calculate centripetal acceleration of an object which is in circular motion by finding the value of tangential speed as the circumference of the circle divided by the time it takes to complete one revolution.